Hi everyone, today we're going to be doing a demo where we build enhanced data processing pipelines with Bacalhau and BigQuery with CEO of Expanso, David Aronchick. So what will we cover in this session? Well, first we'll have an overview of the Bacalhau cluster, then we'll examine the network that's connected to that Bacalhau cluster with Expanso Cloud. We'll then take a bunch of data and load it into BigQuery with Bacalhau, so filtering that data before it gets to BigQuery so we can make sure that only the information we want to work with is going to be in there, which will make things faster and quicker and cheaper in the long run. We're going to pseudonymize that data source, and then we're going to wrap things up and leave you some resources to go and build this yourself. For this demo, we have a very simple architecture diagram, which simplifies things a little bit better. We're going to be actually using way more nodes than this in this demo. But essentially, you have a managed orchestrator in Expanso Cloud that you, with the Bacalhau CLI, can use to interact with and push jobs to various nodes across various clouds and regions on the internet, where that data will be crunched and loaded into BigQuery, which we can then go and take a look at directly, rather than having to go and find all these sources independently. So, with no further delay, David, take it away.
Hey, so we're going to get started and do a quick demo of how you can use Bacalhau and Expanso as a way to improve your overall data processing pipelines on hosted services like BigQuery. So the first thing we're going to do is start with a very simple Bacalhau cluster. Bacalhau is a distributed orchestration system, as you know, and one thing that we really like to highlight is how effective it is at working and giving you a single control plane that works across multiple clouds. Here you can see I have a very simple Bacalhau cluster that spans multiple clouds, but this is a big wall of text. What if we looked at it from the orchestrator's perspective? Well, we're going to actually do that using the Expanso Cloud. This is a hosted service where we give you an orchestrator, and inside that you can see all the nodes. So here you can see I have 20 nodes connected to my network, and these 20 nodes are spread across multiple different locations. Here you can see each of the nodes, what's running, and so on. And in it, we have associated a term, cloud provider here, which says what cloud it's running on. Here you can see GCP, AWS, here we have some Azure nodes and so on, a mix of them all across, and 20 in total. Now, that said, I can operate with very simple jobs across all of the nodes. So if we want to run a very simple process across all of the nodes simultaneously, we can do Bacalhau docker run. There are 20 nodes in total, so we'll do 20 nodes, and we'll use Alpine and just say echo hello BigQuery example. And now what it's going to do is go out to every single one of those nodes on every single cloud and execute that very simple command. It'll take just a second as the container downloads, updates, and runs, and we reach overall consensus that the job is complete. And when we go and select and say describe that job, you can see here hello on each node we've said hello BigQuery example and spit out that standard out for people to read, and you get a whole long rich history of all the information that has been logged and run. Okay, now moving on, obviously that's not just what we're here for, but now you can see we have a single cluster that's operating across everything. Let's begin to analyze some of the data. Now this is going to be the first and only command I run on these nodes that doesn't involve Bacalhau. I'm going to SSH into a Bacalhau node, and on that node I'm going to look at some of the log data that we are processing on there. This is simulated log processing, where it's simply running and pretending that it is doing standard NCSA log management. You can see quite a bit of stuff printing out there, all being generated on the fly. Now, like I said, one of the most standard things for people to do with data like this is to send it into a raw log bucket. You can do that with many of a number of different types of processors out there. We're going to use Bacalhau to accomplish that, and this is done in a batch way. Though we're doing it in a batch way for now, you could do it on an ongoing basis or have the daemon run their process normally. Okay, so now what we're going to do is we are going to do a little bit more streamlined analysis. The first thing we want to do is get it off of those machines, all that log data that we're producing. The way we're going to go do this is with Bacalhau and DuckDB. DuckDB is obviously an incredibly powerful local processor, but you need a place to land that data, and BigQuery is a terrific place to do it. What we've written here is two things. The first you can see is a very simple exporter. This is just using Python. And again, all of this is hosted on our public example GitHub repo. All it does is going to take some credentials in order to write to BigQuery. And you can see all the magic here is in this DuckDB connect. It connects to that raw log file on that machine, that access.log. It's going to read it in and put it into a single column, which loads it into a data frame, and add a timestamp to that. And then from that, it uses BigQuery load job config, where it pushes all that into our data on the cloud. When we go over to our BigQuery console, just to show you, nothing up our sleeve, in our raw logs table here, you can see no data to display. And when we go back here, in order to execute that, we've written a very simple Bacalhau job. Let me walk you through this. First, we have a very simple container here. It's called the Python query container. All that does is take a Python script and then run it. The reason I call it BigQuery is because I've also preloaded some of the libraries necessary to communicate back and forth with BigQuery via Python, but really straightforward. I have it uploading to a hard-coded BigQuery ID. Again, this is something you can either load on your own or use as a template or whatever you like. I also have it looking for local credentials. This is obviously a best practice. You don't want to be passing credentials around. If you need to load them on the machine, you can do that through Bacalhau. Or, even in a more secure way, you can use a vault to load your a key vault or other secret store to load your credentials. I'm not doing that right now, only because I'm trying to keep it simple, but it's very easy to integrate with that. I tell it to look for a specific file, that access.log file, and then here's a little bit of magic that we have. Bacalhau will take an entire environment variable, and in this case, I'm going to actually mount the Python file that you just saw me walking through there into the container itself and then run it. And that's basically it. So now, in order to run that, there really is not much to it. I'm going to cut and paste the job in here, as you can see, just because I don't want to get any of the typing wrong. But to walk you through, it takes that BigQuery job in YAML that I wrote earlier, and then it mounts in that template file as base64, which all it does is it takes this BigQuery, mounts it in here, and then encodes it as base64. And off it goes. Now, what you can see here is it's going out and finding a node that allows to run that particular job. And doing that is going to take just a second here because it does have to download and run that container. But in a few seconds, it will continue. And we're done. When I go to describe the job, you can see here that it spit out a little bit of the standard out that was expected. We rerun our job here. And you can see it's going to take just a second because we actually loaded a fair bit of data in. But momentarily, BigQuery shows us our logs that have now been loaded in from that machine. And to show you exactly what happened here, we're going to count them. And you can see that in just a few seconds, it was able to load 838,000 rows from that machine. Now that is all raw data, and that is only one machine. Let's get a little bit more advanced here. Okay, so now we're going to run that job again, except now we're going to run it over all 20 nodes and upload from each node the raw logs. When we execute again, we can see that it's now executing against all the nodes simultaneously. This is going to take a minute, so we'll just speed it up. And we can see that finished. And when it did, we'll go and check the results. And you can see it uploaded from all the nodes along the way. And when we just page through it, you can see each one produced a raw audit log. And now when we go over to check our number of uploaded runs, you can see that in just a few minutes, we were able to upload 27 million rows from those 20 different nodes. So super powerful, no data warehouse, no special tools. This is just raw Python being executed in parallel against raw files on each of the individual nodes. Cool. Okay, now next, let's do something a little bit more advanced. As you saw in our logs here, we're just at the end of the day uploading raw logs to the to BigQuery. Here you can see that it's pretty big, and on top of that, it's poorly formed. We're just uploading raw text. You can see here that each line gets its own information, but there's no parsing or anything intelligent. And if we were going to go through and parse this, we would now have to parse 27 million rows inside a single database, which is obviously not ideal. Let's clean this up and instead do a more sophisticated way of processing this. I have a second processing Python file here. You can see it. It's the exact same one as you saw earlier, except now we're going to use a schema to upload each one to. Same query, same uploading to BigQuery, except now we're doing some very lightweight processing where we're going to split it up into its individual component parts. You can see that here using generic SQL and DuckDB, but instead of operating that centrally over a central set of clusters, we're going to execute that in a distributed way on each node individually. So we're going to go back to our BigQuery executor, but instead of writing Python 0, we're going to execute against Python 1. And now when we run it, it's similarly going to schedule to every one of those nodes. And now instead of uploading the raw logs, we're going to upload now segmented and processed logs. Again, we'll speed it up because this does take just a couple minutes to run. And when we go over to the BigQuery and look at our log results here, we can now see that the query has been split, or the nodes have been split across everything. So now you're able to do queries and interesting things on like user IDs, timestamps, and so on. Again, all processed locally in the background of those machines. Again, this is the kind of thing where, today you might have to do that using a centralized data warehouse, but by allowing you to do those queries distributed, you both reduce the overall cost and speed your ability to get answers. So you can say, how many times people are accessing this page without even doing a given result on those pages. One thing I want to point out as we move on to our next one is we're actually uploading the full IP address here. This is actually considered a violation of publicly identifiable information and what you're allowed to move. If you have a central data warehouse, this could be considered moving personally identifiable information across country boundaries. Let's see what we can do about that. When I go back over here, I have a new file called log process 2. In it, it's the same code as in log process 1, except here you're going to notice a very specific change. We have a function called sanitize IP. According to many legal opinions, the way to sanitize IP addresses from being PII is to preserve the first 3 octets, but 0 out the last one. Again, very simple thing, very simple to do in Python. The rest of the code remains the same. And so what we're going to do here is take this code, or take the exact same thing we did in the previous step, but now upload it with the sanitized IP address, thereby making it much more applicable and compliant with many regulations. Let's go back over to the command line, or the terminal, to execute that. When I execute it now, again, the exact same code running in the exact same way. It's going to go over to all those nodes and execute that job on there. Again, we will speed it up just a little bit because this does take a couple minutes to run. And so when we go back over and click on our log results, we can see now that instead of uploading the raw results, we have uploaded the IP addresses sanitized. And again, what I want to stress here is not that this was a particularly complicated effort or query, but it was done in a distributed way, and it was done before we moved the data to the cloud. And as you can see, that's not a small amount of data. With more than 46 million rows in this database, we were able to do this in a distributed way and upload them all together. Okay, one last thing. We're still uploading a lot of raw data, which still is really not ideal. What you want to be doing is uploading just the most important things. You want to aggregate things over certain windows to understand what's going on over any given point in time, and still upload things that are extremely important. Let's go back over to Visual Studio Code, and now we're going to look at our last one here. Again, just raw Python. But in this case, instead of uploading straight raw things, the first thing we're going to do is we're going to pull out, using DuckDB, all of our information here into a data frame. And then in that data frame, we're going to say anything that is an emergency, that's what we're going to pass through so that we can detect that very quickly and look at our emergency logs. Anything that is not an emergency, we're going to aggregate. And we're going to look at the status categories of things like redirects not found and system errors, as well as how many bytes and so on and so forth. This will give us an average over those time windows, giving us an overall sense of what's going on, but it means that we're cutting down from that 46 million total that you saw earlier. When we go to update that again, we're going to do log process 3, which is our new aggregator. Again, this aggregator is running in a distributed way. Each node is aggregating its own information and passing it on. And then we're only going to update the change nodes. And you can see it's already happening much more quickly because we are able to process that locally. We don't need to process every row because every row is not important, and so on. And it doesn't mean, by the way, that we're tossing that data out. It means we can certainly add a system that uploads to nearline, cold storage, whatever is appropriate for that. But you can see that in just about the time that I was finished talking here, it's already completed much more quickly than the other log processing. Okay, and now we're going to go over and look at our log aggregates. You can see us run that here. And now when we go over to check out the log aggregates, we can see that here. We're now, instead of uploading all of the raw data, we are uploading by host name only aggregations of that raw data. Now, over those 26 total nodes, we can see the number of OKs and total count, so on and so forth, for each of these individual things. Again, a much more scalable and reliable way to do that, but still being able to maintain things like your emergencies. So when the script found an emergency in the log, it continued to update those, and you can see those here. So we can see that on this particular host name, these were some of the 500 errors. This was the error and the remote log ID and other information that came along the way. So as you can see, this is a much more flexible and powerful way to do that log processing. It still gives you all the power that you had originally, but instead of requiring a central data warehouse to do all that processing, you're able to do it in a much more efficient way, reusing much of the existing compute you have, saving you money and allowing you to act much more quickly in response to your system. Thank you very much.